Welcome to new episode. We will explore how to configure Azure Load Balancer to distribute traffic across multiple VMs, ensuring high availability and performance in this episode. So let's get started. Now, Azure Load Balancer automatically distributes inbound traffic across multiple VMs. This ensures that your application remains highly available and can handle large volumes of traffic without any disruption. Now, internal and public load balancing. Well, for different scenarios, you can use either the public load balancer for internet-facing application and internal load balancer for distributing traffic across internal application within your network boundaries. To handle varying levels of traffic or spikes in traffic, you can integrate VM scale set. These scale set is actually offered by Azure as a service, which will automatically scale the number of VMs based on real-time traffic demand, ensuring your application performs optimally and also saving some cost in the long run. Now, load balancer also needs something called health probe. Well, health probes monitor the health of your VM and ensure traffic is only routed to the healthy instances. If a VM becomes unresponsive, the load balancer will automatically route the traffic to another healthy VMs in the pool. So that is why health probes are very important. To enhance resilience and availability, zone redundant load balancing can be used to distribute traffic across multiple AZs, availability zones, providing fault tolerance in case of a total zone failure. So all this functionality is provided by the load balancer. So let's go to our lab and check out how we can implement load balancer, where we will learn how to create health probes, backend pool, and also the front-end connectivity. So I will see you in the lab. All right, in this lab, we will create a load balancer. So what are we trying to achieve? We already have a network, and in that network, we will have two machines. Now, these machines are running a web server. Of course, in the real world, both will run the identical website, but here I changed the website to present or to show this text, that is web VM01 and VM02, so that if we test it, we can see the connection. Are we connecting to the first one or the second one in the pool? So we have a back-end pool in which we have two servers running our website. Then we will create a load balancer with a front-end public IP, and the back-end will be private as it is. And then from internet, we will try to connect with our load balancer, and the load balancer should give us the connection to any of these machines. Now, let's pay attention here. I have two machines. I have multiple, but for this demo, we are using VM1 and 2. So this is VM1 and this is VM2. Both VM already have a public IP, separate public IP. So they both have separate public IP. VM1 is this one. And for VM2, the public IP is this one. Here I am connected to both computers. And on both computers, I have configured a website. Now, I can close this. So if we go to this public IP, and let's go to browser and connect with this machine via port number 80, of course. My website is running on HTTP, not HTTPS. So we will connect to VM2. If we go to VM1, then we'll connect to VM1. But we don't want this. We want these machines to be behind a load balancer. And we should connect to the load balancer public IP, and the load balancer should connect us with any of these VMs. So before we create a load balancer, let me remove these public IPs. We don't need it. So I'll just go to this VM, click on network settings, click on network card, go to IP config, and simply say, I don't want a public IP. So I will uncheck this option, associate public IP address. So VM1 public IP is now released. Now let's focus on VM2. Network. I'll go to network card, then IP config, scroll down, IP config, and release this public IP as well. So now both machines will have no public IP. So there is no way I can connect with these machines. So it's not refreshing yet, but the public IPs are gone. Perfect. Now if I go to VM1, no public IP, same for VM2. Now we can focus on, this will not work, even how much I refresh it. So now let's focus on load balancer. To create a load balancer, type LB, load balancer. Don't worry about this one. This is the old one. I will create a new one now. So click on create standard load balancer. Perfect. Select your resource group and give this load balancer a name. I will call it NITA LB, load balancer, in Canada Central. So this will be our region. Now we are just creating a simple standard load balancer, and this will be a public one. So public and internal simply means if the front end is public or have a public IP, that is a public load balancer. If the front end have private IP, then it will become the private load balancer or internal load balancer. Now tier will be regional. Regional is good enough for me. Now the next step, this is important. Give your load balancer a front end. So I will click on add a front end. I will call it NITA load balancer front end. It will be IP4. I need one IP address. If you want a range of IP address, you can select IP prefix, but one is enough. Now, I can use the public IP address released from VM1, or you can create a brand new one. It doesn't matter. In the end, you just need a public IP. So why not I just use a released public IP for this demo? So this public IP is released. I will just select that. Then click Save. Public IP is now saved. Next, backend pool. You have to create a selection, a logical group or logical pool of your resources. I'll call it NITAP for pool. Now you will select the network in which you have your virtual machines running. So my web servers are running in VNet 01. So I will select that. Now, do you want to connect with the network card of your machine or with the IP address? I mean, both options will connect you with the VM. Either you can go with IP address and select your VM IP. This is the first IP, this is the second IP, or you can connect with network card. The only difference is, in case of future IP updates, if the IP of that machine gets changed or updated, well, it will go out of the pool and the load balancer will not be able to connect with that machine. So if the IP address is not static, you can choose network card because the network card will stay the same. So let's say network card. Select all the machine which are actually deploying your resources. So my website is running on both machines. I will select that. You can also add more and more machines in the future as well. So I will save it. Backend pool done. Next, your load balancing rule. By the way, we are not using any network address translation for both inbound and outbound rules. We will just focus on load balancing. So click on Add a Load Balancing Rule. These rules are very simple and straightforward, so just, stay with me. I will call it NITA Load Balancer Rule. The name actually depends on the organization's naming convention. So it depends on which company you're working for. I will use IPv4. Now, what is the rule? The rule is any request coming from this front end, means this public IP, will go to this pool. The request will come from TCP protocol and port number 80. It must go to port number 80 at the back end. So this is the rule, where this health probe, we have to create a health probe, where this health probe will tell the load balancer if the service is available or not. What do you mean by that? Well, a health probe, let me put it like this. Health probe. A health probe will keep on checking the health of both machines and tell load balancer that if this machine is down, then send all the requests to the other healthy machine. So basically, it simply means that if the machine is not working or the service is down, the load balancer will not send the person or the request to the unresponsive machine. So let's create a health probe. I will call it NITA health probe. Now, which protocol it will check? HTTP. Which port it will check? 80. Now, you can have multiple websites running there, which can have multiple paths, but I only have one web page and one website, so default path is good enough. And my health probe will check the health of the service every 5 seconds. So this is the frequency. Click Save. And that's it. Now, session persistence, these are all advanced options, not a compulsion. But this means if the user gets disconnected because of any drop in the network, and then the user gets reconnected, the session will wait for it, and the load balancer will connect the user to the same computer the user connected earlier. So your session will be persistent. Now, of course, if you are disconnected for more than 4 minutes, then you will get a new random machine according to the load balancer rule. So I don't need to configure it. Click Save. All good. No need for outbound rules because nothing is going from these machine to the world. The world is connecting with the machines. Next. And create this load balancer. And that's it. Creating a simple load balancer was this easy. Now, while this is deploying, I can go back to the load balancer. Still not mentioned here, but I know the public IP I used for load balancer. If I go to public IP, I used VM1 public IP, I think. Yeah, this one. So if I copy the IP address and I go there, see, I'm connected to VM2 still. But remember, this might be saved in the cache. So always try to open this website on a new incognito session or on a new device, maybe your phone or tablet. So I will wait for this deployment to finish. Perfect timing. It's done. Now I need to create a brand new computer. So I will just create a non-persistent machine, which is just a sandbox. Pretend this machine is a brand new laptop or your employee is using this machine. They will go to, internet browser and paste your public IP. And if your configuration is right, yes, this person connected to VM1. Now let's go to a private window. Connect again. Let's see. Yeah, continue to site. VM2. See, the load is being balanced. Sometimes you're connecting with VM1, sometimes you're connecting with VM2. This is how the load balancer works. Now, if one of the machine goes dead, well, the load balancer will put all the requests to the alive machine. So that's how you configure your load balancer, and that's it for this lab. I will see you in the next one. Welcome back. I hope the lab was clear. And now you know what load balancer actually do. Both type of load balancer can be used by organization, that is private and public. And it is that easy to actually implement it. So in summary, Azure Load Balancer ensures reliability and high availability by distributing traffic efficiently across multiple VMs in the backend pool, while using health probes and scaling based on the demand or the spike in demand. With options like public and internal load balancing and zone redundant load balancing, your application can maintain optimal performance and uptime. Thanks for tuning in today. By configuring Azure Load Balancer, you can ensure your application is always responsive and scalable to meet your traffic demands. I hope you will be able to implement it now. I will see you in the next episode. Stay tuned.